Okay guys, in this video I'm going to, sending this out, is to basically show you that there is a new packet that I have given that has to do with functions. Now remember, the last packet that we've already completed, let me zoom out a little bit more, is we've already finished this packet here. Everything that had to do with domain and range, writing them in interval notation, being able to tell if a function or relation is a function, remember that? Vertical line test. So we've been practicing on everything that has to do with domain and range. So now we're shifting, which is still in the same unit, to functions. All right. So this particular packet, just to be clear, you have a 3-day weekend. So I was able to, before I left 1 hour early on Friday, to get this to my lab students. They have the hard copy packet. I went to the biomedical lab, or the biomedical class, and I gave this to pre-AP students. But those of you in the makerspace, you did not get this hard copy. So please know that, and I'll show this really quick. If you hear some sounds, it's my son. But please know that if I go to the internet real quick, if I go back to Schoology and courses, give me 1 second. All right, so I just wanted to show in Schoology real quick. So I just wanted to show that right here for pre-AP, I went ahead and I reorganized the way that Schoology is set up. So I just want to show you where your resources are. So the syllabus is still here in the pink folder. The cheat sheet is a resource. Eventually I'm going to make a folder that's called Teacher Notes, and I will begin to upload those maybe sometime this weekend, hopefully. But I want to just show you guys right here for the green folder that says Unit 2 Functions. If you click on this one, this was the late post that I did, the sheet that was out of the textbook, where we had to do, and we did it in class, numbers 33 through 44, and we went over in pre-AP. We went ahead and we did all of these about, doing function notation, plugging in values or expressions. So we've already done this, and this was the sheet of paper, or the image that I went ahead and did there. So that's homework 1. This is the second page to that same homework. Now, if you go here where it says Unit 2, Relations, Function Worksheets number 1, if you go here, there's about maybe 20 pages, as you can see. This is everything that we've covered up to this point. So again, the first packet that you have, here's everything for that. But as you keep going, it will then change into, right here, equations as functions. So those of you that did not get the hard copy, pages 10, okay, all the way through 20 is the packet. So when you come in on Tuesday, guys, I will provide you with a copy of this. But for right now, everybody, I'm going to go back to the document camera. Do what you can on a sheet of paper. So if you do not have the packet, I repeat, make sure that you just fill in everything on a sheet of paper. Then I will give you about 15 to 20 minutes to come and transfer your answers. All right? So the homework that is due on Tuesday, October the 12th, is going to be, I want this section filled out. I've given you the answers. You're going to fill out numbers 1 through 4. Alaric. We're going to turn and finish that. You need to do the back side. Okay, and again, I am going to give a couple of answers away. And the homework, so that's the notes, is the first page. The second page right here, so where it says homework number 3, equations as functions, this right here is your homework 2. Okay, so this is what I'm taking for a grade. In the video, I'm going to do a couple of these problems here for practice, and you can fill it out and finish the rest. But this is what I'm taking for a grade. Now, if you ask me, Ms. Mosley, is the backside also due? No, that starts the new information with function notation. Do not do anything from here onward. So again, this page here is the homework that we're going to grade. And the first page, front and back, is just the notes, all right? So let's jump into the answers here. All right. All right, so here are the answers. So let's just go back as a quick review. I'm going to make this a short video. We've already talked about how equations have equal signs, right? Well, equations and functions, you see how it says equations as functions? They're one and the same, okay? So in this case, what it says, and I talked to you about this before, so let's say I say y is equal to 3x plus 7. Okay, it looks just like an equation, but the difference is you see you have 2 unknowns. So here's my input, which is x. My output is y. Remember, this guy, when I plug it in, once I sit back and calculate this side, it's going to equal y. All right, that's what makes it a function, because you plug in something respectively and then out comes someone else. All right, remember the definition of a function is a relationship between two variables. All right, so here it says functions can also be represented by an equation or a rule. So again, there's some kind of formula or equation I have to use, or a rule that I have to follow, which is a function. And what will happen is the equation will generate an ordered pair, which is x comma y, taking an input value of x that results in a certain output for y. So again, x can be anything that you can plug in to your rule or your function. Once you calculate the right side of the equal sign, it will then give you a specific certain output, which is y. So again, the equation will generate ordered pairs, x comma y, when you take in an input for x that results in a certain output for y. Instead of all ordered pairs, so there's a bunch of infinite ordered pairs that can happen. Negative 2.7, 1.6, 3.4, 10.5. You can even do decimals, right? And once you plug it in, there is a specific y value. So there's these infinite number or sets of ordered pairs, and it will form a what, guys? A line or a curve. All right, so that's the fill in the blank for that there. You can pause the video. All right, so now as we keep going, it says, think of a function like a machine that takes in x values and produces a y value. So in comes the x value that you want to figure out, what happens to y when you plug in a certain x value. As it gets input into the function machine, it's going to output a certain y. So in comes something, out comes something else. X value, which of course is our domain, is also called an independent variable. So you get to pick whatever x values you want to check and see who depends on that value, right? And y values is called the dependent variable because he's dependent on whatever x value you plug in. All right, so that's pretty straightforward. So now I'm going to go to actually graphing. Complete each function table, then graph the function. So they wanted us to plug in -5 into x right here because these are our x values, which is my domain. I'm plugging in -5. -5 plus 4, guys, is -1. I plug in -4. -4 plus 4 will give me an output of 0. And then I'm just going to show real quick, if you're like, well, where is she getting this from? She's just telling to me verbally. But again, here's your function. Y is equal to x plus 4. This is my input. They wanted us to plug in -2 for x, so I substitute it in. I add 4 to it. I get a positive 2, which produces this ordered pair of -2, comma 2. So we plugged in -2. We got out positive 2. Sorry about that. Now I plug in 0 into the function. 0 plus 4 is 4. So now I've made the ordered pair 0, comma 4. So now I'm going to finish the table off there. And very carefully, all I did is I started plotting those points. So I went 5 to the left, 1 down for -5, comma -1. -4 to the left was this x-intercept here. Here I went to -2, up 2. And then I went to 0 and went up 4. And then I used the straight edge of a piece of paper and I graphed it. All right, let's try the ones that you guys don't really like, which are usually fractions. So I'm going to do number 4 now. My side and do the correction. Again, my eyes were going to this 3/4, like with the 4, but really this one, guys, it had -3/2. So I'm going to work this again. So I got -3/2, multiplying it by -2/1, add 2. This is still 6, but over 2, plus 2/1, multiply by 2 to the bottom and top. And so I'm going to move a little quick so it'll make it confusing, but you'll be okay. Now keep in mind, the interesting thing about this is just 3. I don't even have to do this because as soon as I did -3 times -2, it's 6/2. 6/2 is 3. Everybody see that? And then 3 plus 2 is 5. So again, this was 3. When I multiplied those two fractions plus 2, the answer is 5. So here, guys, I'm just going to fix this. Right here, the output will be a 5. So let's just put them right here. So -2, I output 5. Okay, here's my x, there's my y. All right, now I'm going to plug in 0. If I plug in 0, I still will get 2. And if I plug in 2 now with a positive, it's going to be the same kind of math. Let me do it here. 3/2 times 2/1 plus 2. Again, this is 6/2. 6/2 is 3. 3 plus 2 is 5. So also when I plugged in 2, positive, yeah, I got out 5 again. And then when I plug in 4, so let me do that one for you. So remember, this is supposed to be a 2 here. I'm multiplying by 4 over 1 plus 2. Y equals, this is negative 12 over 2 plus 2. Negative 12 divided by 2 is negative 6. Negative 6 plus 2 is negative 4. So when I plugged in positive 4, I got out negative 4. So this is 4, negative 4. All right, so let's graph this and see what we get. Sorry about that again. Okay, I just was using the wrong number in the denominator. Here we go. So let's plug in negative 2, 5. So let's go 2 to the left, and let's go up. 1, 2, 3, 4, 5. So right here is negative 2, 5. 0, 2, 0 for x, go up 2 for y. We're going to also go to 2, 1, 2, and go up. Something's wrong with that point, I can tell already. Now 4, negative 4, let me just do something real quick, guys. 1, 2, 3, 4, go down. 1, 2, 3, negative 4 right here. And notice how if I go 2 and up 5, notice how I'm like weird up here. It should be a line. So let me check my arithmetic real quick on what happens when I plug in 2. Oh, it was a negative, that's why. So I had negative 3 over 2 times 2 over 1 plus 2. Okay. So negative 6 over 2, there it is. I see it now. This negative 6 divided by 2 is negative 3 plus 2. We should have got negative 1. Okay. So negative 1. So this should not be a 5. It should be a negative 1. So now if I go to 2 here, I'm going to go down 1. And that makes sense. It looks like it's in alignment. All right. Sorry about all the blunders. All right. So now I can just take a straight edge on the edge of the paper if you don't have a ruler. And then you can just lightly connect these points with a linear line. And that's that. Okay. Notice how this line goes up to the right. It has a positive slope. And notice how this one goes down to the right. See, it has a negative slope. All right, so that takes care of those two. Try number 2 and number 3. All right, let me go on the back side. The video's getting a little long for you guys. I feel like these are pretty straightforward. Again, watch this negative one though, okay? So notice, and I'll do the fraction, not this one. So watch how if there's a minus sign in front of the x, or even on the coefficient in front of x, be careful with your substitution. So let me do this one for you. Y equals 1 minus 1/3 x. And the 1 is positive. So they want me to plug in negative 3, 0, 3, and 6. So if I plug in negative 3, I got negative 1/3. X is going to be negative 3 over 1. Remember, again, it makes it easier to deal with fractions when you put whole numbers over 1. So now I'm going to ignore this part. Let's multiply across. Negative 1 times negative 3 is 3. 3 divided by 3 is 1. So one more time. This right here was negative 1 times negative 3 is positive 3 over 3. See, that's 1. All right? So this becomes positive 1. And then I'm dropping down that because it's a positive 1, I'm putting a plus, and then I'm doing that. You see? So the output is 2. Okay? So when x was negative 3, the output is 2. Look at that carefully, okay? I'm going to do it again. So on here, let's put 2. Let's go to 0. Now again, anything times 0 is just 0, so this whole term is going to go away. 0 is just going to be 0. The answer is going to be 1. So again, if I plug in 0 here, 0 times this number is 0, and then I have 1. All right, so I'm going to show you it again with positive 3. So I have y is equal to 1 minus 1/3 times positive 3 over 1. Y equals 1 minus, and again, I'm just going to cover this up, and this is 1 times 3 is 3. On the bottom, 3 times 1 is 3. 3 divided by 3 is just 1, so my output is 0. So when x was positive 3, the output was 0, which is an x-intercept. 3, 0. All right, now I'm going to do it once more, doing 6. So y is equal to 1 minus 1/3, and then 6 over 1. So I have y equal 1 minus, and then I'm covering this up. 1 times 6 is 6. 6 divided by 3. 6 divided by 3 is 2. So again, what was I doing here? I was doing 1 times 6 over 3 times 1, which was 6 over 3, and that's where I got 2 from, everybody. Okay? So 1 minus 2 is negative 1. All right, always take your time. So this is going to give me a negative 1. Now I can plot those points. So when I'm at negative 3, 1, 2, 3, I'm going to go up 2, 1, 2. When I'm at 0, I'm going to go up 1. And then I'm going to go 1, 2, 3, comma 0. And then I'm going to go 3, 4, 5, 6, and down 1. So it's a nice steep line. Then I'm going to use a straight edge best I can. And I have those points there. Remember to draw a line going through them. And then put arrows on the end because it's infinite. Sorry, you see I missed it. Do better than me. All right, so that's pretty straightforward. Everybody get on that, number 6? And let me also say that here, in this case, it's the same thing. These are your x values, and they want you to plug in negative 1, 0, 1, 4. Plug them in individually here, get out y, and then you'll make a table. Okay, so I'm going to just do one of these. I'm not going to keep doing fractions for you guys, but I'll do number 12. So I would make a t-table, and I got negative 12, negative 6, and 3. And then carefully on the side for my scratch work, I would say negative 2/3 times negative 12 over 1. And this is 24 over 3. 24 over 3 is positive 8. Negative 2/3. And then I'm going to put negative 6 over 1. And this is positive 12 over 3, which is 4. And last one, negative 2/3 times 3 over 1. Sorry, the bird. Negative 6 divided by 3 is negative 2. So that's all I want for numbers 12, which you're getting the respective range values and y's. And then if you were to graph this, you know, we could graph them. Now, the cool thing is when y'all come to class, if everyone has this done, 7 through 14, right, and we get this, we're going to start using the calculator to now let the calculator spit out our lines, okay? So I'm going to end this video here. It's pretty lengthy, but again, I hope you understand how to do it. I also, again, hope that you know how to go on to Schoology and find the resources for class. Please stop alert, stop alert. And so you should be able to find everything you need here. Again, page, I think 10 or 11 is the worksheet. And then I also uploaded the outline of all the things that will be in Unit 2. I know it's called Unit 3, but it's really Unit 2 for us. And then, of course, after we do functions and relations, we'll continue on. And then, of course, I'll see if I can squeeze in real-world graphs, and then we'll be taking a quiz soon. All right? See you guys later, and that ends this video.